Welcome everyone. Welcome to the 9th Global Feature Store Meetup. Today it's our first meetup since the summit, actually. So we're really happy to bring back the meetups back since August. So it's really fun. Today we have a very, very interesting, very special presentation for you guys today. But before we get started, maybe Jim, do you want to get a kickoff?
Yeah, I'll just introduce. Thanks. My makeup, I had a makeup problem, so my camera's off, and don't worry about it. You're not missing anything. So we had the summit, as Natalia said, on the 12th and 13th of October. The videos are all live. Go check them out. If you just Google Feature Store Summit videos, you'll find them. I don't need to give you a link here. So today this is a continuation of the meetups that we've been running. If you're interested in talking at a meetup, just ping us. I think you can actually do it from the meetup page, and try and get involved, and please chat away as well on the meetup page. So today we have the pleasure of having Snowflake. I think this is the first time Snowflake are talking at the Feature Store Meetups series, and we have Simon Field, who's Snowcat Technical Director. And Snowcat is something I've read quite a lot about, and in particular Snowpark. I think a lot of people are really interested in Snowpark. It's like the new processing framework, and high performance feature processing sounds just about right for us. So this is really exciting, and I'm really looking forward to hear what Simon has to say about what they're doing in the space. We're going to finish up with a Q&A, so you can ask questions. This is a Zoom meetup, and you can see there's a Q&A button at the bottom, at the very bottom of your picture. You can chat as well, but we'll try and answer questions from Q&A first, and chat you can chat with each other on it. And if you're using the chat functionality, make sure that when you click on it, there's a link to hosts and panelists at the bottom. And if you're just sending it to panelists, then everyone won't see what your message is. So a little bit about the community before Simon kicks off. featurestore.org, there is a Slack channel from the summit. There's about 900 people on it. And we have a newsletter where we keep up with the latest developments in feature stores. And if you write on feature stores, there's a Medium page where you can submit your blog as well. So without further ado, I'll hand over to Simon, and really look forward to this.
Thanks so much, Jim. Right, let me just share my screen again. Which needs to work. Is that working?
Yeah, it's perfect.
Brilliant. Okay, great. Well, nice to meet everybody virtually. So yeah, today I wanted to talk to you a little bit about Snowflake as a platform, and then how we kind of fit in the data science space, and how you can use Snowflake more particularly around feature store and engineering. So first of all, I guess let me introduce myself. So I've been in Snowflake for 3+ years now, but I've worked in kind of data warehousing and big data all my career, and more recently in the last kind of 10 years focused quite a lot in the area of data science as that field has grown and become interesting to explore. So that's kind of a little divestiture I made from data warehousing, just because I felt the need for something new to learn, and it's been really interesting as this whole space has evolved. So Snowcat stands for Snowflake Customer Acceleration Team. So our team works very closely with customers, as you might expect from the name, with new features and functionality that we're bringing out on the platform, and early adopters of that, and getting feedback into our product organization. So we're actually a part of our product organization rather than a part of our sales organization. And we kind of provide that direct linkage into the product organization, so they get really fast feedback on new functionality as we deliver and develop it. And yeah, so kind of one of those features, as Jim alluded to, I've been doing quite a bit of work with, is this new functionality called Snowpark, which is a new way of interacting and developing and coding against Snowflake. And this has quite a bit of suitability for this particular workspace, particularly data science, and obviously around feature storage and engineering as well. So we'll get into a bit more detail on that as we go through. So yeah, I'll just do a quick introduction into the space, and then I guess there might be people on the call that haven't heard of Snowflake and are not so familiar with our platform. So I'll talk a little bit about the Snowflake data platform and how it might fit within a data science lifecycle. And then we'll get into the meat of it, talking around kind of feature storage and feature engineering. And I know at the kind of Feature Store Summit, there was kind of two themes or two areas of focus around build versus buy. So I'm going to talk around, what some of our customers are doing in terms of building on the platform, their own feature stores, what they might be doing and using for that, and then some of the partners that we work with who also have solutions that are built or have integrations with Snowflake. And I'll talk a little bit about some of the customers that are doing this, but we've got a lot of customers using Snowflake, over 5,000, and a lot of those use Snowflake specifically in part of their data science lifecycle. And then hopefully we'll have enough space at the end for Q&A. So I think this audience is very experienced in this space already. So you're probably familiar that, one of the great challenges, and data scientists spend a lot of their time in the preparation of data and the collection of data and getting it into the right shape for machine learning. And this is one of the kind of big challenges, and also one of the big kind of efficiency challenges of working well and building and deploying data science models with efficiency. And one of the other challenges is that a lot of organizations through kind of evolution have got, lots of different places that they store data, multiple copies, and that's spread across many complex systems. And obviously data warehousing and data lakes and those kind of technologies are looking to try and consolidate and centralize that information into a place where data scientists can more easily collaborate and work on it and get it into the right shape to feed into models. And then kind of interesting and not the only study, but Forrester, did a study of, where organizations were struggling from an ML model point of view. And over 60% of organizations was talking about not just the data preparation side of things, but how difficult it was to get a model from, trained and ready to productionize and into that kind of operational context. And once they had it there, being able to maintain it and make sure that it, stayed fresh as data and the business evolved with time. So let's kind of talk a little bit about Snowflake and kind of how it fits within the kind of data science space. So at a high level, you've got this kind of prepare and source data, kind of build models, and then deployment as the kind of steps you move through. And one of the areas that kind of, my screen just went black. Hopefully it didn't for everybody else. Yeah, one of the areas where this is kind of the areas where Snowflake, really excels. So we provide a platform for storing, all data. So not just structured data, which is kind of what we first came to the market with, and semi-structured data, but now we also support the storage of unstructured data as well. So being able to bring in, documents and images and audio files, and then being able to run machine learning models over those to extract and classify information from them. So one of the other key features of Snowflake is the ability to share data between Snowflake customers or accounts, and that's evolved over time into data sharing as a technology capability within the platform. And on top of that, we've built a data marketplace where hundreds of data providers, some of whom you'd probably be very familiar with as household names in the kind of data provider type market, and then lots of other smaller organizations as well, supplying data sets through Snowflake with this sharing mechanism into other organizations. And when you do that, you get access to the data immediately. It's literally like having that organization's table directly within your own Snowflake account. So any changes they make to the data to keep it live, you'll see immediately within your own account. So one of the other capabilities of Snowflake is around just the way that our processing engine works. So we're one of the first technologies to separate storage from compute. We allow many compute clusters to be operating over the same data set. There's really kind of no limit. We operate across all three major cloud vendors, so Amazon, or AWS, Azure, and GCP. And so people can have Snowflake running in any of those clouds, and indeed some of our customers have it running across multiple different cloud providers and replication between. So we really make it very easy for people to use the platform. And then the other area we're focused around is kind of data governance, as you might expect when people are bringing a lot of data into our platform. So we provide really advanced data security features, data discovery features for PII, the ability to mask sensitive data and secure sensitive data down to field, column, and at row level. So really granular data security. So yeah, as I mentioned, the Snowflake Data Marketplace allows you to kind of bring data in from third parties without even having to kind of do the ETL yourself. The data provider is going to be doing the ETL and sharing the table with you. Through that mechanism, we've seen organizations sharing data with other business partners bidirectionally as well. So not just kind of third-party data providers, but business partners as well. And so a real kind of ecosystem developing around getting access to data quickly. And with the kind of addition of the unstructured data capability, that's kind of really interesting as well to see how that develops around the marketplace. So the kind of processing capability of Snowflake originally was based around SQL and fundamentally is a kind of database processing engine. But most recently, we've added additional language support and APIs to access and code and develop against Snowflake, and Snowpark, which I'll talk about in a bit more detail today, is one of those capabilities. So we support not just SQL now, but you can develop functions in Python, in Java, in Scala, or in JavaScript. And then you can use the client-side DataFrame APIs to develop and operate against Snowflake as well. This multi-cluster compute means that individual data scientists or individual workloads can be kept separated from each other with no conflict, scaled up and down as required to meet demand. And you only pay for however long a compute cluster is up and running for, and they're instantaneous to start and instantaneous to shut down. So you don't have to wait minutes for the cluster to start up. It's immediately available. And then we've added additional functionality with automated data pipeline processing with Snowpipe. So auto ingesting files into the platform. And then once the data's landed inside tables inside Snowflake, we have change data capture streams and tasks that can be set up to move the data through a series of steps to get it into the right format as you process it and transform it. And then, as I said, kind of like the tooling that people typically are bringing to Snowflake and bringing around Snowflake from a data science point of view, very often Python-based processing and tools that make use of Python and the frameworks underneath it for data science, but also Spark and R and Scala and a number of these different partners that you can see here obviously make use of those technologies as well. So that all works through our kind of standard integrations that we provide. We're providing kind of the building blocks for these partners and tools to sit on top of. And so if we kind of look at this from an end-to-end perspective, there's a whole bunch of atomic capabilities here from Snowflake, and then really our partners and tools integrate and work with those in a seamless way. All of this can be developed using SQL commands, so you can create and define these different types of objects and processes to run inside Snowflake using SQL, and also using these new APIs that we have to move the data through kind of from collection through feature engineering and through into training and deployment for models. So let's kind of now shift focus and talk around feature stores specifically and feature engineering with Snowflake. And so if we kind of first of all just touch on the workflow, we've kind of already touched a little bit on this, but kind of the major steps that we'll move through are, sourcing data. We've talked about the data marketplace as a means for doing that, but also bringing in data from, any kind of source systems, any kind of source file formats into Snowflake. Then you're probably going to go through some kind of discovery exercise or data profiling or EDA over the data to understand, particularly from a data scientist point of view, what's the distribution of this data? What does it look like? How clean is it? What do I need to do to it? From a transformation perspective, in order to get it into some kind of model ready state. And once I've done that, then I really want to kind of store it somehow or provide some kind of view over that data to catalog it and make it accessible for not just myself, but potentially other members of my team. And then we'll want to push the data out for training and potentially also for prediction and serving of the data for inference. Or we can now do the inference inside of Snowflake using some of the other language integrations that we've built. So kind of what is the feature store trying to, I guess the challenges that it's trying to solve for. And again, I guess this audience will be kind of very familiar with a number of these challenges and looking for technologies to solve these problems. So, really within a feature store, we're trying to centralize the management of features, store them as efficiently as we possibly can and catalog them and make them generally available to not just ourselves, the individual, but also to a much wider team. And that might be not just data scientists as well. It might also be that we want to use them in some kind of downstream business reporting process to understand how well models are performing over time. So we can actually start monitoring these things and seeing the value that we're generating from these machine learning models. So we want to define the features just once, if we can, and then reuse them many, many times in many potential models that we want to build. We want to serve the features both for training and inference, and that could be offline, so batch, large numbers of records that we want to both train with and predict on, but it also might be that we require online serving, so single record lookup with low latency to support online application. And then really all of the kind of capabilities here are driven around trying to provide consistency and reproducibility from a data governance perspective in the data supply chain for data science. So, avoiding things like data leakage, ensuring that at any point in time when I look at the data, I'm getting a correct view of the data at that point in time, and being able to go and rebuild features back through history whenever I define a new feature. And so, as I mentioned at the start, there's a couple of different ways that customers tend to think about this, and actually also a blend of these two. But generally, people look at Snowflake's capabilities and other open source technologies that might already be using as part of their data engineering supply chain, and then use those same technologies to build out their own feature store kind of capability. So commonly we see things like Feast, very commonly DBT, which is a really nice kind of transformation framework based around SQL, Apache Airflow for scheduling, and then tools like Amundsen for cataloging and Great Expectations for data quality monitoring and measurement. So that's on the build side. And then on the buy side, we work with a number of different data science technology partners, some of whom have kind of built their platforms on top of Snowflake exclusively, and then others that have built integrations with Snowflake, but also support other platforms as well. And the two main ones that we work with in the space, or two or three that we've kind of work with specifically in the feature store space are Rasgo, Tecton, and at Scale, who have key integrations to our technology. So let's go into a bit more detail around the build. So this is kind of really how can we as Snowflake and our services support customers that want to go down this route. And so we provide some tooling and templates and best practices to assist with this. So there's kind of two typical different design approaches that I see taken, and again, sometimes a blend of these as well. So on the left-hand side, the kind of materialized or persisted route where people will actually transform the data, physically store it in its kind of end state within Snowflake, and they'll be building data pipelines to do that. Within Snowflake, we've got some kind of key capabilities for data. My screen's gone black again. Let's come back. For supporting this, some of which I've touched on already, but we support time travel queries, so you can kind of query as of a particular point in time. We also have something called zero copy cloning, which enables you to kind of snapshot data without actually physically copying the data when you do that. And you can kind of keep these snapshots for as long as you need to, as data in the main tables that you've snapshotted kind of evolves. And I mentioned, different kind of ways of working with data inside Snowflake. So we've had semi-structured support in the platform pretty much from day one, and quite a lot of the way I see people manage this inside of Snowflake is to use some of our semi-structured data management SQL functionality and storage functionality for storing complex types inside Snowflake. And that might be persisted and stored over physical tables that they've built inside of Snowflake, or we also support external tables over cloud file stores. So don't necessarily have to ingest all of the data into Snowflake to use this approach. And the kind of dynamic virtual approach is more kind of meta store or metadata store driven, where the tool that they build are built based around kind of definitions of features, etc., will dynamically generate SQL at runtime, and then present that either for training or for prediction as needed. As I say, quite often see a blend of these two approaches as well. So this is kind of typical design pattern, high level, that we see customers going down. So, they'll be sourcing data, whether that's kind of from their own data sources or second party, third party through the marketplace and Snowflake data sharing, using our Snowpipe service to ingest data into their data warehouse or their data lake environment, and typically storing the data in some kind of modeled form. So they'll be moving it through a series of kind of data transformation layers until they get it to the point where, they've cleaned it and it's kind of raw ready for ingestion into kind of a feature store model, data model. And then at that stage, they'll have built processes to support that ingestion into this, whatever the data model is that they've defined to store features. They'll build standardized transformations to operate over the top of that. To scale the data or normalize the data, whatever it is they need to do within the feature store. They'll potentially provide statistical summaries of the features as well and monitor those with time. Again, looking for kind of decay in the data and change in the data over time. And then, provide some kind of cataloging capability over the top of it. And ultimately, want to pull the data out at the point where they want to either train models. That's typically done externally from Snowflake, in Python or clusters, Python clusters or Spark clusters, depending on the scale of the data. And then also for prediction as well. So that could be directly served from Snowflake. I'll talk a little bit about the kind of performance expectations for directly serving data online for prediction, or they may introduce some kind of caching technology to support that as well. So let's talk a little bit about Snowpark and where that fits within this process. And the two main areas where you're going to probably use this is both to source data, and transform data to get it into Snowflake, and then transform the data once you've got it inside Snowflake. So about 6 or 7 months ago, we brought out the Scala functionality, and that's still in public preview, but being used widely by our customers. So that's a Scala-based DataFrame API. And today, actually, we've announced at a kind of another event that we're doing, the Python support, so the Python DataFrame API in Snowflake in Snowpark. And then in terms of the compute processing inside of Snowflake, we push down processing through effectively generating SQL from those DataFrame APIs and creating functions that can be computed inside of Snowflake, whether that's inside our compute clusters, what we call virtual warehouses, or in some of our serverless services. And those functions can be Java, Python, which, as I said, is new, and we've had JavaScript support for quite a while. Interestingly, we also support external functions. So that's kind of access to a REST API to pass data out to do something and get the result back. And that can be very useful for models that you might have published externally as a REST endpoint, and being able to make use of those, or even transforms through this external function support. So kind of the detail of what that looks like. So there's kind of the data frame side of this, where we define joins and filters and projections, what columns we want to look at, using a data frame like API. And then the definition of functions, which could be defined in that client side code, will effectively be packaged up and turned into user-defined functions inside of Snowflake. So they'll be registered inside Snowflake, either as a permanent function or as a temporary function, and can then be reused going forward. So for example, if you're building or training a model, and you then trained that model and you're ready to deploy it, you could potentially deploy that as a prediction function inside the database, and then pass rows through it to get a prediction back. So here's a kind of example of the type of function that could either be written by hand or generated through Snowpark's API on the client side. In this case, it's calculating distance between 2 points, but it could be any kind of transformation function, basically. The nice thing here is once we've defined and created this function, as I said, it can be persisted inside the database, and then it's not just that accessible to that client-side API if I want to reuse it in my Python code, but I can also use it natively through SQL in the database. So it's very flexible how I can reuse these functions once created. And so the typical kind of use cases we're seeing for this already is people building custom file or data transformers to transform specific file types that maybe we don't have native support for today. Using it, for ingestion, for classification over those data sets, extracting data over those data sets, doing feature engineering and transforms, and as I mentioned earlier, model predictions, and then building all of this into pipelines that they can use to automate the whole end-to-end process. And those pipelines could be, Python code written in Snowpark that they then schedule with things like Airflow. Or it could actually be embedded into the kind of serverless processing environment that we provide. So it's kind of, again, flexibility there for customers. So kind of we look at how do people typically operate, over features. If they're dealing with very wide data sets, maybe they'll transpose those, unpivot those into tool format, and quite often see customers store the data in this tool format. So here I've got the MT cars kind of hello world data set for data science. And there's, as you can see with the SQL on the right hand side here, some relatively simple functions that will transport that data or transpose that data into tool form, either dynamically, then I can operate over it in this kind of tool form. The value column gets stored as a variant, which is a kind of multi-type, semi-structured data type inside of Snowflake. So we can store all of those values, whether they're numeric or non-numeric, all in the same column efficiently, and then we can operate over this, in its tool form pretty efficiently. So that's a kind of typical pattern C, particularly if there's a lot of sparsity in the data. So there's a lot of nulls in the wider table. You can drop the null rows on ingest quite efficiently. In fact, that's what SQL is doing, is dropping the null rows, so storing it very efficiently inside Snowflake that way. So once we've got the data standardized inside Snowflake, then we can provide standardized functions and views over the top of it. So here you're actually seeing both SQL code and the Snowpark API underneath it doing functionally the same thing. So I have a numeric summary view here that's using that tool formatted data to provide this kind of single table summary for all the columns that I point it at. So when I look at a specific table, penguins, I can get kind of summary level statistics from a numeric point of view, or also for categorical data. So you want to probably look at that a little bit differently to the numeric. And you can see in the Snowpark syntax here that I kind of, the code functionally is very similar. So I'm defining a table or view that I'm operating over, the filters that I want to apply, columns that I want to either see or drop, how I want to sort the data. And in this case, because I'm working with the new Python Snowpark API, I can convert directly to a pandas data frame to then do some further client-side processing with that very efficiently. And there's various views here that we provide that operate over that tool table format to make it easy to create these summaries and do this analysis without having to write long-winded code to do it. Similarly, pre-built kind of transformations, so kind of modeled, I guess, on the scikit-learn pre-processing functions. So things like binarization, normalization, various scaling functions, and they all work in the same way. So this kind of SQL syntax at the top here is using a table function, calling that table function, passing it a set of columns it wants to apply it to, and then any additional arguments that are needed to support the function. And then the output of that is kind of what you see at the bottom in the table here. So we get the transformed value, the original value, some metadata in terms of how it generated it, so we can reapply this function if we need to in the future. And then as before, you see the kind of Snowpark syntax for this, the DataFrame API syntax for that same SQL below the SQL. And then, this data table format here can be re-ingested and stored back in our feature store model. So it's easy once we've got it in the standardized format to write it back into the feature store. So we can store not just the original values, but the derived values as well. So in terms of, so I've got the data formatted and transformed and in the feature store in the kind of format that I want, either to then do some kind of build some kind of predictive model with it, or I've built the model and I want to pass data through the model with the transforms in its transformed state in order to get predictions. So there's obviously a kind of two different modes there. Really is like doing it in batch or bulk on large volumes of data, kind of the offline mode, and then the online mode. So just doing some kind of testing here, and this was actually done through the Python API, although I've passed it a SQL string in this particular instance. But you can see here I'm pulling back a feature vector based on a random row ID. So the row ID is just a SHA-2 function of the primary key. And I'm getting uncached around about half a second. So I think on average about 0.4 of a second. And for cached, where the query's been run for that particular RID within the last 24 hours. Obviously, this one's run immediately after the uncached version, but I get it back in about 0.2 of a second. Now, for a lot of applications, I know that that's probably not good enough for real on-time online applications, but for many, it is good enough. And so we do see customers using Snowflake not just as the offline store, but quite often as the online store as well. We provide a number of different connectors and APIs to access that. So depending on what your application programming language is that your app's built in, you're probably going to be able to get access to the data through Snowflake through one of these APIs. And one of the most recent of those is the REST API. So you can actually kind of directly run queries and connect through the REST API to do this kind of stuff as well. Okay, so kind of just talking around some of the open source technologies that we're building integrations with. So I'm sure many of you be familiar with Feast as a project. So we're developing the kind of offline and online connector support for Feast with Snowflake. So we've got branch linked here to that code, and we started working with some customers and testing that with those. And we're also working with some other partners on kind of deeper integration or joint integrations with this as well. So there you kind of using Feast as well, and we're looking at where we can join up the dots between Feast and Snowflake and those partners. And then we're looking at what other integrations we might be able to add in. So in terms of sourcing and transforming, as you know, Feast is just kind of a storage based model, but you need to transform the data externally pre-ingest. So we're looking at what we might be able to do around Python Snowpark for that, for kind of the data transformation and preparation side of things. And then also kind of for batch inference, automating that. So if you're interested in that, please do. My contact details will be at the end of the session, and please do reach out. I'll be interested to work with anybody that's interested in that. So kind of moving on to partner solutions. I kind of touched on a few of these already, but I'll just go into a little bit more detail on some of these. So Rasgo, I think, presented at the Feature Store Summit last month. So Rasgo's built their technology on top of Snowflake, and they use many of the kind of underlying functions and capabilities that I've talked about, but they're providing that as a product and a service. So if you don't want to go through the pain of building something yourself, you can make use of their service. They provide both a UI interface and a Python-based interface into that, Python SDK. Tecton are building integrations into Snowflake as well from their platform, again, making use of this kind of Python Snowpark API. So that's coming. And then AtScale, who's been a partner of ours for quite a long time, around the BI tool and the semantic layer. So if anybody doesn't understand their technology or know their technology, they provide like a semantic layer over the top of data lakes and data warehouses where you can define measures and dimensions and hierarchies, etc. And then through their tooling, they're now built Python integration to that, and building out kind of data science functionality so that you can read features into Python from their semantic model. Effectively, it will push down the SQL into the database engine that it generates from the definitions in the semantic model. And likewise, once you've built and defined new features on the Python side, you can publish those back into their semantic model through their API as well. So that's a nice integration. And then some of the other partners at the bottom here are kind of more around feature engineering, although H2O, who's been a partner again of ours for quite some time, I saw last month announce that they've brought out their kind of own feature engineering, feature storage technology, co-developed with AT&T, who's also a Snowflake customer, very large Snowflake customer, and they're making use of Snowflake and some of this kind of capability around data data transformations within that platform. So I'll just touch on a few customer examples. So Chipotle, it's a kind of restaurant chain in the US, which I'm sure our US-based attendees will be very familiar with these guys. So they use Snowflake, and actually through the COVID crisis, one of the data sets that we had in the data marketplace that gained traction very, very quickly became the kind of most used data set, unsurprisingly, in our marketplace was worldwide COVID data down to low levels of kind of geographic region, national regions. And that was very useful for them to help build models so they could better understand, you know, the impact on their business as COVID moved regionally and declined regionally around the country. Count, who's a kind of Equifax company, are using Snowflake for kind of fraud, building fraud models, and again, you know, making use of a number of those kind of underlying capabilities that I've already touched on for that. And then Instacart, kind of interesting online retail, food grocery retailer, again, US based. Really interesting blog they've written here. In fact, all of these links at the bottom here are to blogs and events that they've presented at, talking about how they use Snowflake to build out the features that they need so that they can run very, very regular real-time forecasting models to support their business, and all of that running in a kind of operational context. And then another one more recently presented, Coalition, and again, like a webinar that we had with them. They're interesting because they've kind of built their own platform again. And they've used, I touched on this technology earlier, DBT, which is kind of popular data transformation, SQL-based transformation and templating framework. They're using DBT to help with the kind of feature transformation and building. So links to all of these in the deck, which you'll be able to touch on and go and look at. So just to kind of summarize and close, and then we can move on to the Q&A side of things. So if you want to learn more about Snowpark and the API, that's very new, particularly the Python API is just announced today. So you'll notice the date on this Snow Day event here for North America is today, and then EMEA and Asia Pac tomorrow. But if you go and register at the link at the top here, you'll be able to go and look at the recordings of these, or even potentially if they're in the right time zone for tomorrow, go and watch them live. And we're talking a lot more about this kind of Snowpark API and how it can be a really good fit for both data science and data engineering workloads. And just to close out, so, you know, really Snowflake's providing a bunch of core components and enabling technologies for people to build on top of, whether that's building their own feature store in-house or buying through our services and technology partners that have built on top of these functions as well. So today we support SQL, Java and Scala, JavaScript, through both kind of the functions and Snowpark API. And then this Python Snowpark API that we've announced today is in private preview. But again, if you're an existing Snowflake customer and you're interested in trialing and working with that, then please reach out to me on the links provided, one of the links provided here. I'd be happy to put you in touch with the right people so that we can give you access to the Python-based API. Okay, I think, again, I've got a few links at the back of the deck here as well. So when we share this, you can go and, you know, get some further reading and some further information. But with that, I'll kind of hand it back over and see if there's any questions that people want to ask.
Thanks, Simon. That was really great. And we feel privileged that you've announced the new Python support in Snowpark, I think ahead of time, because I saw the time on the other announcement later. I
think we clashed by, yeah, they're 30 minutes behind us, right? So maybe I got a chance to.
Yeah, so we have a world first here at the Feature Store Meetup. Before we're going to go to the questions, Natalia wants to run a poll Natalia, you there? Is the poll ready?
Yes, all good. So let me just.
Okay, so can people just click on the poll link at the very bottom? Is the poll up yet, or?
It's up now. So.
Okay, we got a poll here. So before we go to the questions, just please click. It says 1, I am a student, data scientist, ML engineer, product lead. I'm none of those, so I don't know which one I clicked, but no, I'm not a student.
Oh, panelists can't vote.
Okay, panelists can't vote. Okay. How many years of experience do you have working with ML and data infrastructure? How would you describe your experience with feature stores? Just learning, evaluating. Yeah, they're all very positive. No options for people to really, give out. Anyway, keep going. You're doing great, everyone. I can see the answers are flying in here.
Maybe do you want to start taking the questions? Maybe. Jim?
Yeah, we have some questions. One of them was, can you share a link to the feast branch? I think that's in the deck. So you're going to share the deck, right, Simon? You've mentioned it.
Yeah, I'll share that with you guys, and I guess you'll send it out or make it available, right?
Yeah.
Or the best place to put it up on the Slack channel. I don't know what's the best way of sharing it with you.
Well, Natalia will send out a mail to everyone, I think, and including the video, and I guess we can include it with that, right, Natalia?
That's perfect. Exactly.
Okay. I think we probably got as many are going to answer. There's 60%. I think that's generally how many participate in elections, is it not? At least in the Anglo-Saxon world, that's what we get. we don't tend to get more than that. So quick summary. Mostly you're ML engineers, half of you, and quite a lot of product managers, which is cool. You seem to be relatively experienced. There's a kind of a bimodal distribution going on there. And I would say you're right on the money, Simon. Quite a lot of people have been working on feature stores already, or at least evaluating them. Okay. Sweet.
Good. I'm glad I kind of understood the audience that I might be talking to.
You pitched it right. So let's hit on the questions. I have a couple, probably, if we have a minute or two after. Firstly, from the anonymous attendee, do you see the catalog being an internal component of the feature store or an external component of the warehouse? And I guess they mean feature catalog by saying catalog. And
yeah,
is it just part of Snowflake? It's just the tables in Snowflake. Or?
You can look at this obviously in a few different levels. So one of the nice things about Snowflake is kind of like the database catalog, around objects, so tables, views, columns within. All of that information is stored centrally inside Snowflake. So I mentioned that you can have different clusters that you can start up instantaneously against the database. That information schema or the database catalog is always available as in the service. And in fact, to query it, quite often you don't even need compute to query it. It's kind of just part of the service. So that's kind of raw technical level metadata, so to speak. And then, I see customers using sometimes existing data cataloging technologies that they're already using, for their data warehouse. So they'll just reuse that or repurpose that when they start building out these kind of feature store frameworks with the technology.
Yeah.
Equally, quite often see, and I think this is the reason why we're seeing, feature store vendors starting to come to the market, is it's one of the core capabilities that obviously gets provided with a feature store. And there are things that are kind of, I guess, pretty specific, to a feature store versus just a general data catalog.
I think EDA is kind of thing, exploratory data analysis.
Exactly, providing those kind of statistical summaries.
And provenance and feature definitions, all that kind of stuff,
Yeah, exactly. So I think that's a big reason, or one of the big reasons why we're seeing people adopt those kind of tools, whether it's open source or one of the partner tools I mentioned to do that.
Great. Esteban Donato has the perfunctory question about Spark. And can you give us a little bit more detail? How is this different to Spark? I mean, you mentioned Python and Scala, but and you had a little data frame in there and it was compiling down into SQL. So is this distributed? I mean, I guess that's the other question. How does it compare? How distributed is your Python or your Scala, and how does it compare to Spark? And is that data frame support that compiles down in SQL, is that kind of like koalas from Databricks, or is it something different, I guess?
No, it's all right. So if you looked at the API, which I guess if you are familiar with Spark, let me just move to a slide where I might have some code on it. There we go. So if you are familiar with Spark as an API, then this code probably does not look unfamiliar to you. So, you know, hopefully that will help customers making a transition or who are using both. And that was kind of one of our intentions.
But for the pandas stuff, I mean, is it distributed or not? I guess as many people.
Well, so the Python API is more modeled on or similar to PySpark than pandas. So both those kind of.
So you have your own data frame. They're not actually pandas.
Yeah, effectively. So when I define the table here and the object that I'm passing into the table, so my session or my sesh.table. That's referencing a database object inside of Snowflake. So that could be a view, a table, an external table that's pointing at files out in a data lake store. You know, anything that we support from a database object perspective, tabular object perspective. And then the functions that you see below that are obviously doing things like where clause type filtering, and then projections and sorting, but you can do group by and rolling windows and all of those kind of things that you'd expect.
So that CM pandas object we can see there, is that actually like a pandas data frame object? And if it's not, if it's your object, what kind of coverage do you have with the pandas API?
Yeah, no, so
what level of coverage, I should say?
Yeah. So at the moment, it's just like the Spark Python or Spark Scala API. So you can see, I think, Jim, like if you look on that CM pandas, basically I'm pushing down the transformations in the top part of the code, doing the correlation calculations. I'm not over a big data set here, but it could be a massive data set I wanted to do that over. And then the result output of that is small enough that I can use the toPandas function to bring that back to the client to then work with that you know, aggregated or subset data that I've done the main processing for on the Snowflake compute side of things. And I can move the data, you know, back and forth that way.
Okay, all right. So okay, great, thanks.
But yeah, effectively, you know, wherever you're using these DataFrame API functions, under the covers, we're generating SQL commands and running that as SQL inside of Snowflake.
All right, cool. So Mark Derdzinski, he asks, are there any plans to support feature retrieval with streaming architectures? So publishing feature updates to a Kafka topic. So I guess that means if you're doing feature engineering in Snowflake, maybe you're computing aggregates and so on, that the sync would be a Kafka.
Yeah, let me just go back to my architecture picture here. So we see customers kind of implementing in a couple of ways at the moment. So generally they'll push, if they need real low latency serving of a persisted or transformed feature, then they'll you know, lower than the 0.4 of a second that I talked about you can get from Snowflake uncached. Then people will be using some kind of caching technology like Redis or you know, NoSQL database, or even kind of like an OLTP SQL database to store those. We are working, so we've got this kind of ability to ingest data today in micro batches, but we're working on a lower latency ingest feed processing. Will get us to much lower than where we are today, which is around the kind of 30-second mark from kind of source to committed in table. So we'll be able to get much lower than that with the thing that we're working on there. And we are looking at other ways of moving data through Snowflake with lower latency as well. So we've got a number of different projects working on that. We don't support writing to Kafka at the moment. We've had a few customers that are interested in it. So again, like all of these things, I guess when you work in a product organization, it's generally based on customer demand. And if we felt there was, you know, good enough, strong enough demand there, that would definitely be something we'd look at.
You think real time is the general direction, more to
yeah, well, moving to lower and lower latency. I don't know whether.
Yeah, I mean that can mean pressure features, or can mean lower latency access to retrieving features. Yeah, and I guess what the other thing there that we see a bit is where people are using Kafka to both, generate the events to compute the features in, and then you push your computed features back into Kafka.
Yeah, I should have mentioned actually, I guess again on the ingest side of things. So Snowpipe, which you're seeing on the left-hand side there from the source data, supports, basically being triggered by file landing in your cloud file storage as one mechanism, but it also has a REST API that you can work with to trigger it, and we've also got a Kafka connector for Snowpipe as well. So if it's on the ingest side of things, which I know was not where the question was, but if it is on the ingest side of things, you can definitely stream data in from Kafka topics.
Okay, so we have a question here from Manir Contractor, which is, are there specific recommendations around how we can connect HopsWorks and Snowflake?
I guess I might hand that one over to you, Jim, actually.
Yeah, I mean, we actually support, HopsWorks supports tables in Snowflake as external feature groups. So you can actually keep your data in Snowflake. You can even do your feature engineering in Snowflake, and we push down the SQL effectively to Snowflake. And then what we do, however, is that, for example, when you're doing, you're creating training data, it'll read up the data from Snowflake. It'll do the aggregations or whatever. It'll get it back as a data frame in Spark with Spark connector, and then we do the joins in Spark. But I have one question. I think we'll finish off with one more question, just in terms of performance, right? Because Snowflake is well known for its performance, right? So what kind of, in the scheme of the machine learning pipeline, where do you think, that the benefit you get from Snowflake performance? We see things like point-in-time joins, or they're not super fast, right? To create training data, feature engineering, large-scale aggregations. Where do you see the real kind of benefits of your kind of separated, compute and storage kind of architecture?
I think, the separation side of things means that it makes it very easy to operationalize things, because you can, completely isolate different workloads from each other without any interference. So that's very, very helpful, and it can be, right-sized accordingly to the demand. And with serverless options that we've got now for a number of these different services, it will scale itself up and down within the limits that you define to support, whatever the data volumes are. So I think that's definitely an area where we've got a huge amount of strength. We've always been really strong to support, managing and transforming, semi-structured data and structured data, complex data efficiently inside our engine. And I think, some of the things I've touched upon today, we're working on. So our time travel today kind of goes back 90 days in terms of the storage, and we're looking at potentially what we might do with that in the future. There's lots of areas where we can we know that we can look at and improve on. So
brilliant. So thanks a million, Simon. Very interesting talk, very interesting questions. I'd like to thank our audience. You've been so polite. No one's even mentioned the shots that have been fired in the benchmarking wars. Also, I said nothing. I just mentioned, but thanks.
It's a bit of a to and fro at the moment. So
yeah, it's if you hang out on Hacker News or Twitter, like I kind of tend to do, then it's the kind of, like, put it this way: no publicity is bad publicity. Yeah. So I think both of you benefit from it. But in any case,
I think so. I mean, like, clearly we both started at different places, and we're moving, more and more onto each other's turf. It's only natural that people will look to measure us, and we hope they do, right? Certainly from a Snowflake perspective, we're confident that when people look at our technology, they find it very easy to use and manage, and it performs very well for what they need, and it's very flexible. So
okay, that's the marketing pitch. You heard it here, folks. Thanks, everyone, and see you next time.
Thank you. Thanks, guys.
All the best. Bye now.